Good afternoon. Today I'll talk about a study on moisture sources to Southeast Australia during the 2017-19 drought period. This study is a collaboration with researchers at the University of Vigo in Spain, University of Lisboa, Portugal, University Federal of São Paulo in Brazil, and colleagues at UNSW and ANU. The preliminary analysis I'll show here was run by colleagues in Spain and Portugal. As many of you know, Southeast Australia experienced one of the most severe drought in 2017 to 2019 due to rainfall deficit during 3 consecutive winter seasons, something unprecedented in the historical rainfall record. The Bureau of Meteorology notes that these 3 years were the driest on record in the Murray-Darling Basin for any 36-month period starting in January. Here you can see the Australian rainfall deciles from the combined 3 years for the cool season. Droughts in Southeast Australia have been associated with anomalous conditions in the Pacific and Indian Oceans, such as the El Niño Southern Oscillation and Indian Ocean Dipole. While a strong Indian Ocean Dipole occurred in 2019 and may have amplified the rainfall deficit in the region, this cannot be the only driver for the 3 consecutive year drought. In addition, temperatures in the Pacific were neutral. To understand what may have caused the severe drought, we took a different approach and looked at the sources of moisture for the Murray-Darling Basin using a Lagrangian model. We used the Lagrangian flexible particle dispersion model called the FlexPart. The FlexPart is applied to track air parcels and identify moisture sources and sinks that contributed to the recent drought episode in Southeast Australia. We used the area interim data from 1980 to 2019 to calculate the standardized precipitation index and to identify the drought events. The top row shows the sources of moisture for the Murray-Darling Basin, so regions where evaporation exceeds precipitation. The middle and bottom rows show the contribution of oceanic and terrestrial sinks of moisture respectively, so regions where precipitation exceeds evaporation. Climatologically, the main source of moisture comes from the Tasman Sea, which is consistent with previous studies by Chiara Holgate and colleagues. When looking into the anomalies for individual years, we see that this source was negative in autumn and early winter in 2017 and 2018. In 2017, soil moisture was still high, possibly due to the unusual wet winter in 2016. However, the decrease in the terrestrial moisture and the reduction in the usual oceanic source of moisture accentuated the drought in the following years. So this preliminary analysis suggests that the anomalous deficit of oceanic moisture transport to Southeast Australia was the primary reason for the meteorological drought in 2017 and 2019. Thank you.